What if the hours you spend exploring digital worlds were not a guilty pleasure, but a genuine workout for your brain? Today, we are diving into the science of video games and cognition, following 4 landmark studies that track gamers from elementary school all the way to the operating room. By the end of this video, you will understand how gaming can sharpen memory, accelerate spatial reasoning, and even help surgeons tie knots faster, all while learning the boundaries that keep play both healthy and productive. Let us begin with the largest data set to date, the Adolescent Brain Cognitive Development Study, better known as the ABCD project. Researchers with the National Institutes of Health scanned the brains of nearly 2,000 children aged 9 and 10. They compared youngsters who played at least 3 hours of video games every day with peers who rarely played at all. In standard tests of working memory and impulse control, the heavy gamers came out ahead. They pressed buttons faster without sacrificing accuracy, and they held more information in mind when asked to track shifting shapes and colors. When the kids lay inside an fMRI scanner, the regions that support attention and memory lit up more efficiently, almost as if their neural circuits had been doing regular wind sprints. Before parents celebrate unfiltered screen time, the same study reported a small uptick in ADHD and mood symptom scores, still below any clinical threshold, but large enough to remind us that every coin has 2 sides. Brain gains do not replace sleep, exercise, or face-to-face friendship. Think of games like powerful spices in a recipe. A little transforms the dish, too much overwhelms the palate. Now let us rewind to a classic experiment from the University of Toronto that tackled one of the most persistent gaps in STEM education. For decades, researchers have observed that, on average, men outperform women on tests of 3-dimensional mental rotation, an ability vital for engineering, architecture, and advanced mathematics. In 2007, a team asked female students with limited game experience to play an action title for just 10 hours spread over a long weekend. When they retook the spatial test, their scores shot up to equal those of male players who had been practicing the same game. Even more impressive, the improvement lasted for 5 months without additional training. The takeaway is simple. Spatial reasoning is not fixed at birth. It is a skill the brain can remodel quickly when the right challenge appears. So far, the news sounds relentlessly positive, but science rarely moves in straight lines. A recent paper cataloged under PubMed ID 3341958 tested a different slice of cognition called visual short-term memory. The researchers compared seasoned action gamers with non-gamers on tasks that required remembering precise details of flashing objects for just a few seconds. Surprisingly, the 2 groups tied. Gamers were faster and more accurate at focusing their attention, yet the raw storage capacity of visual memory did not budge. In other words, games seemed to train the spotlight rather than enlarge the warehouse. That nuance matters because it reminds us that cognitive advantages are specific. Video games are not magic pills. They are targeted workouts that hit some mental muscles harder than others. Speaking of targeted workouts, let us jump from the living room to the surgical suite. A 2023 review in the medical journal Clinical Imaging looked at how gamified education platforms affect radiology trainees. The tool of choice was Kaizen, a web app that delivers daily quiz questions, tracks streaks, and awards badges for mastery. Across multiple residency programs, learners who used Kaizen not only answered more questions, but retained anatomy details longer, and reported higher motivation than peers stuck with traditional slide decks. Other studies of medical students found that those who grew up playing console games performed better on laparoscopic drills, steering cameras smoothly through simulated intestines. One trial even supplied a Nintendo Wii to novices and documented faster knot tying after only 5 hours of virtual practice. These findings echo a larger trend. When educators borrow scoreboards, avatars, and instant feedback from the gaming world, learners show up, stick around, and level up. What mechanisms drive these gains? Neuroscientists point to dopamine, the brain's reward chemical that surges when we predict a challenge we might beat and spikes again when we actually succeed. Video games are built on an almost perfect schedule of uncertain rewards, just hard enough to be thrilling, not so hard that we give up. Reproduce that pattern in a classroom or a surgical simulator, and attention follows automatically. Of course, not all games are created equal. Fast-paced shooters demand split-second aim and peripheral vision. Real-time strategy titles emphasize planning and resource juggling. Puzzle adventures stretch logic and pattern recognition. Choose the genre that trains the skill you care about. Parents might pair action games with strict timers to hone reaction speed while capping adrenaline overload. Teachers might wrap foundational material inside a turn-based quest so students learn at their own tempo. Medical mentors could let residents compete on leaderboards but require reflection sessions to translate joystick moves into tactile awareness in the operating room. Let us pause for a quick reality check. Every hour spent gaming is an hour not spent doing something else. The ABCD study linked longer gaming sessions with slightly later bedtimes. Excessive play can crowd out sports, reading, or social events. On the flip side, banning games outright ignores their potential as deliberate practice. Balance lies in active supervision. Set clear boundaries, encourage a variety of game genres, and schedule regular offline breaks. That approach lets gamers harvest cognitive benefits while keeping mental health in view. Now, what actionable principles can we all take away? First, brief but focused exposure matters. The Spatial Skills Study achieved transformation in 10 hours, not 100. Sprint sessions of intense practice often beat long marathons. Second, transfer requires similarity. A puzzle game that rotates 3D blocks will not teach you vocabulary, but it will prep your visual cortex for tasks that need mental rotation. Third, motivation multiplies learning. Badges, streaks, and friendly competition convert repetition into a self-driven quest. When possible, bake these mechanics into any training program, be it chemistry flashcards or flight simulation. Fourth, context controls outcome. Children benefit most when adults guide game selection and debrief what they learned. Medical trainees gain when supervisors link in game metrics to patient safety checklists. Fifth, self-monitor. Notice how you feel after gaming. Are you energized and alert or groggy and irritable? Your body keeps better score than any app. As we near the end, let us revisit the big picture. One massive population study suggests that regular gaming fine-tunes youthful brains for attention and memory. A quick intervention erases a gender gap that has hindered generations of women in spatial reasoning fields. Focused game practice correlates with better surgical performance, and gamified curricula make dry subjects sticky. At the same time, not all cognitive domains are equally touched, and too much screen time can chip away at mood and sleep. The science supports gaming as a tool, powerful, adaptable, but best wielded with intention. If all this evidence has you rethinking the way you play or teach, here are 3 parting challenges. This week, pick one game that exercises a skill you value: strategy, coordination, or logical deduction, and limit your play to 20-minute bursts. Next, if you are a student, build a micro-reward system into your study routine. Points for completed flashcards, badges for consistent streaks. Finally, if you are a parent or educator, co-play with your child or learner. Ask questions while you game, connect virtual victories to real-world goals, and model healthy limits. Thank you for spending these few minutes leveling up your knowledge. If you found value, tap like, subscribe to OPED Media for more science-backed insights, and share this video with a gamer or a future surgeon in your life. Remember, game on, brain on, and keep learning.